Imagine this. For 300 years, physics has explained almost everything. Why apples fall, why planets orbit, why stars explode, why time slows down near black holes. It gave us electricity. It gave us GPS. It gave us satellites. It gave us smartphones. Physics built the modern world. But there's one problem. One deep, uncomfortable problem. And no equation has solved it. Not even the greatest minds in history. Not Isaac Newton. Not Albert Einstein. Not even Stephen Hawking. And today, we're going to talk about it. Welcome back to Global Impact, where we explore the universe without fear. If you love deep ideas explained simply, subscribe right now, because what we're building here is different. Physics is built on two massive pillars. First, quantum mechanics. Second, relativity. Quantum mechanics explains the smallest things: atoms, electrons, particles. Relativity explains the biggest things: stars, galaxies, black holes. Quantum mechanics was built by scientists like Niels Bohr and Werner Heisenberg. Relativity was built by Einstein. And here's the crazy part. Both theories work perfectly. Quantum mechanics predicts experiments with insane precision. Relativity predicts how gravity bends light, and we have literally photographed that bending. Physics works. So what's the problem? The problem is this. These two theories hate each other. When we try to combine quantum mechanics and relativity, the math explodes. Literally, the equations produce infinities. Nonsense results. Broken logic. It's like trying to mix oil and water. Here's the battlefield. Black holes. Near a black hole, gravity is extremely strong. Relativity. But inside it, matter becomes incredibly small quantum. So both theories must work together. But they don't. That's why physicists have spent decades trying to build one ultimate theory. Something called quantum gravity. Some believe it's string theory, supported by physicists like Edward Witten. Others explore loop quantum gravity. But here's the honest truth. We don't know. Physics does not yet have a single equation that explains everything. And that's not even the biggest problem. Now we go deeper. Even if we solve quantum gravity, there's something else physics cannot explain. Consciousness. Physics can describe your brain as atoms. It can describe neurons firing. It can describe electrical signals. But it cannot explain why you experience anything. Why does red feel like red? Why do you feel fear? Why do you feel love? Physics can describe the mechanism, but not the experience. This is called the hard problem of consciousness, and no equation solves it. You can measure brain activity, but you cannot measure experience itself. That's a boundary. Let's be clear. Physics is not failing. Physics is honest. Science works by measuring. If something cannot be measured, science struggles. Does that mean it doesn't exist? No. It means our tools are limited. Even Einstein admitted that our theories are approximations of reality. The universe might be deeper than mathematics. And that's not weakness. That's humility. Here's the twist. This problem is not depressing. It's exciting. Because it means discovery is still alive. If physics already solved everything, science would be finished. But it's not. Right now, somewhere in the world, a young student might be thinking about these problems. Maybe in Ethiopia, maybe in India, maybe in America. The next breakthrough might not come from a famous professor. It might come from someone watching this video. That's the beauty. Physics has a problem it can't solve. Not because it's weak, but because reality is deeper than we thought. And that's what makes this universe incredible. If you enjoy this deep dive, subscribe to Global Impact. We're not here for surface level content. We're here to think. Drop a comment. Do you believe everything can eventually be explained by physics? Or do you think some mysteries will always remain? I read every comment. And if you stayed until the end, you're exactly the type of thinker this channel is built for. See you in the next exploration.